All right, so I'm live with 52 weeks of Swift, and today I'm going to cover typecasting in Swift, and that should be kind of interesting. I'm going to go ahead and get started here and share my entire window here, and you'll see here that I've got the typecasting window set up here. So basically, in Swift, the idea here is that let me just get this working like this. Okay, so the idea here with Swift, with typecasting, it's a way to check the type of an instance or treat that instance as a different superclass or subclass from somewhere else in its own class hierarchy. Typecasting in Swift is implemented with the is and as operators. And you can also use typecasting to check whether a type conforms to a protocol, as described in checking for protocol conformance. And so we've got this here, and we can kind of start playing around with this. So I'm going to move this over here. And in fact, I think we don't want that. Yeah, we want like that. That would be perfect. Something like this would be good. And then I'll keep this window here. So first step, what we're going to do is we can see this first snippet defines a new base class called media item. Okay, I like it. Let's go ahead and take this and throw it in here. And I've got this going. The next snippet defines two subclasses of media item, right? So let's first take a look at this media item here. What does it do? Well, it's got a mutable variable var, and we're going to initialize a self.name variable. And then the subclass here would be able to leverage that. So let's go ahead and do this. We'll have a subclass of movie and a subclass of song. Makes sense, right? And so in this case, the super would go through and it would inherit right from the base class here. And we would make an instance of the self.name. And then we would include an additional component here, which is the director, which is really the modification for the movie. And then for the song, we would initialize an artist here. So we've got a couple changes here. So the final snippet creates a constant array called library, which contains two movie instances and three song instances. And the type of the library array is inferred by initializing it with the contents of the array a literal. And so the Swift's type checker can figure this out automatically, that they have a common superclass of media item. And so it infers that media item is for the library array. Okay, so that's kind of interesting. And I guess we'll just paste this whole thing inside of here. So this is definitely pretty fancy stuff here. We have base classes. We have a base class. We have two we have two subclasses of it, and then in addition we create a immutable array here that is able to actually make instances of all of those. And so if we go through and we run this code, it doesn't give us an error, right? We've actually got this thing working because the type of the library is inferred to be media item, which is again pretty cool. And so the items stored in the library are still movie and song, but if you iterate over the contents of the items, you can receive back they're typed as media item. They're not typed as a movie or a song. In order to work with them as their native type, though, you need to check their type or downcast them to a different type. So that is actually very interesting. So for checking type here, what would we do? We would use the type check operator is to check whether an instance is of a certain subclass type. I do this in certain languages for sure. And the type check operator returns true if the instance is of the subclass type, and false if it's not. The example below defines two variables, movie count and song count, which count the number of movie and song instances in the library array. Okay, so that's pretty logical, right? Is let's say that I have a bunch of production code here that does use the same style, and then I have a bunch of records that I want to process, and I wanted to do analytics right on those records. This is the kind of code I'd probably write is, hey, let's check the type. And if it's type movie, let's count it. If it's song type, count it. And that way we can actually figure out what we've got in our catalog. Like, let's say you worked for, which I have worked in my past, you worked for a media company like Sony, for example, one of my previous employers. Maybe this is some kind of analytics code I would write is make a mutable variable, right? Because we're going to need to change this as we iterate through, write a for loop for item in library, which is again the array here. If item is movie, movie count +1. So that's definitely pretty slick here because I just have to, the is will basically know that I'm talking about types. And if I go ahead and I run this, we'll say media library contains 2 movies and 3 songs. So definitely liking this typecasting style here. And so a constant or variable of a certain class type may refer to an instance of a subclass behind the scenes. Where you believe this is the case, you can also try to downclass to the subclass type with a typecast operator as ? Or as ! Because it can fail. It comes in 2 forms. A conditional as ? Returns an optional value of the type you're trying to downclass. The forced form as ! Attempts the downcast and force unwraps the result. Use the conditional as ? When you aren't sure if it'll succeed. This form will always return an optional value, and the value will be nil if it wasn't possible. Use the forced only when you're sure it will always succeed. This force will trigger a runtime error if you downcast to an incorrect type. So very interesting. So this example iterates over and prints the appropriate description for each. To do so, it will need to access each item as a true movie or song and not just as a media item. So if we go through here and we do this, it's going to go ahead and try our downcasting here. Let's go ahead and try this thing out. And for item in library, if let movie item as movie, print this. Otherwise, make it a song. So if we go through here and we run this code, the movie Citizen Kane, director Orson, the song The One and Only, right? So this code is very seamless because again, we use the optional syntax. We weren't forcing it. This starts by trying to downcast, but because the item is not, then it just doesn't process it. Downcasting a movie fails, right? And so we see how that would work. Now, typecasting for any object, there's 2 special types for working with non-specific types. Any can represent an instance of any type, including function types. Any object can represent an instance of any class type. Use those when you need explicit behavior and capabilities they provide. So here's an example of using any to work with a different types, including function types and non-class types. Okay, let's go ahead and try this out. Go through here, we have a var, any, depend. We append a bunch of things to there. Okay. And this thing contains 2 integers, 2 doubles, a string, a tuple. So it's got all kinds of types in here. And then basically to discover the type that's known only to be of a type any, you can use is or as in a switch statement. Oh, okay. So basically, wow, this is a lot of code to to figure. This is definitely more of a kind of instructional example here. You wouldn't do this in a real world, but basically, like, show me every type, right? And this would go through here, and it would print out basically an X point, a movie, right? It kind of goes through and slurps everything up, and so we can see how this works. So definitely a pretty cool lesson today. I learned a lot about the typecasting in Swift. In fact, it's very, very intuitive and not as complicated as I thought it would be, and definitely something I would use in production code. So next week, let's see, I will cover what's next here would be nested types next week. All right. See you next week.